Alright, so get ready for a nice challenge on compositions of functions. So when we compose two functions, it looks something like this. You'll also see it written as follows, where h of x is really just this f of g of x. It looks like the word fog, but it's not. This is that operation of composition of functions. And we can rewrite it as f parentheses g parentheses x. So it's always read as f of g of x. So there's this cool GeoGebra tool in which we're challenged to find one of the functions with which we're composing a second function to create a new one. So in this case, we have this function that's given to us, g of x, as 2x plus 1, and we have our input being given as this number 4. Now we don't have to use a numerical input, we can work strictly with algebra, but for now let's use this to illustrate our point. So what we're told here is start with g of x, take an input, a value of x, and then put that into f. So in our case our input is 4, so we're going to find g of 4, which is going to be 2 times 4 plus 1. We're going to take this output, which is 9, and we're going to input it into our function f. That's the purple function. But hold up a second. We don't actually know what the function f of x is. We just know that it outputs this 71. Our goal is to then find a function f of x, which will make this happen. So pause the video right here and see if you can find one or two that would make this work. Alright, I hope you've given it a try and you've unpaused the video. Here's one that I've come up with. So if f of 9 is supposed to be 71, then f of x could be x plus 62, right? Or perhaps you can get a little bit more creative and you can say f of x might have been x squared, so that would have been 9 squared, or 81, subtract 10, which would be 71. So maybe x squared minus 10 is our function. Or you could really step your game up and pause here if you want to try something. And you can get f of x as a power of 2. Let's say 2 to the x subtract 3, which would then become 2 to the 6 plus 7, which would become 64 plus 7, which also gives us 71. So you already see 3 options so far for representations of this function f. How many do you think there are? Let's go back to our original so you can see what we started with. And you can see how h of x is this composition of two functions, g and f. Questions you want to ask yourself? How many options are there for f? If we did it in reverse order and started with f and then put that answer into g, would we get the same output of 71? What would the algebraic compositions look like? All this and more when we meet.